Dear students, today we shall study the ninth standard chapter number system. In this number system, the contents we are going to study are: first one is introduction to the chapter. Second one is we will learn about the irrational numbers. Third content is real numbers and their decimal expansions. Fourth one is representing the real numbers on the number line. So fifth one is fundamental operation on the real numbers. So and lastly, we are going to study the laws of exponents, that means laws of indices on the real numbers. Now students, we will see the different types of set of numbers. Students, now if we come to the number system, number system, it means it is a system in which we study different types of numbers. So number system means it is a system in which we study different types of numbers and their relationship and the rules given in them. So before going to study the number system, students, already you are all familiar with the different types of set of numbers. That means natural n. So the set of n, set of w, set of z, set of q, and etc. So now we will recall the different set of numbers. First one is natural numbers. So natural numbers means they are the counting numbers. So they are the counting numbers. We are going to use them in the day-to-day life. That means 1, 2, 3, 4, 5, 6, etc. So they are all called as, so counting numbers are called as natural numbers. That means they are always positive numbers. So natural number is represented by, or it is denoted by, so n. So n equals 1, 2, 3, 4, 5, 6. So this is a set of natural numbers. It contains only positive numbers. Counting numbers are called as natural numbers. So coming to the second type of number, set of number, that is whole number. So whole number means if 0 is added to the natural numbers, if 0 is added to the natural numbers, then we will get the set of whole numbers. So therefore students, all natural numbers and 0 form the set of whole numbers. So if you observe the set, so we will represent the whole number by W. Then it is denoted by W. W equals 0, 1, 2, 3, 4, 5, 6, etc. So if you observe the set of whole number and the natural number, so there is only one difference is there. So what is that difference? So it is, so if you observe the set of natural numbers, so it will be the counting numbers 1, 2, 3, 4, 5, 6. So if you observe the set of whole numbers, so 0 is included. So here, if we add 0 to the natural numbers, we will get the set of whole numbers. Okay. Students, next we will go to the integers. So integers means, so if we add, so negative numbers. So negative numbers to the whole number. Negative numbers to the set of whole numbers, we will get integers. Integers. So that means, so 0, so 1, 2, 3, 4, 5, 6, etc. So to the, they are the numbers to the right side of the 0. Right side of the 0. So if we add negative numbers to the left side, so that means, so minus 1, minus 2, minus 3, etc. So we will get the set of integers. So the set of integers is represented by I or Z. Set of integers is represented by I or Z. So it includes both positive and negative numbers. So with 0. So if you observe this set, so from 0, the right side the numbers will be the positive numbers and the left side of the numbers will be the negative numbers. Therefore, set of integers so includes natural numbers, 0 and the negative numbers. So this can be written as 0 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 4 and etc. Okay. Students, next we coming to the another type of set of numbers. So they are rational numbers. Rational numbers means they are the numbers so which can be written in the form of P by Q form. That means they are expressed in the form of P by Q. So where P and Q are the numbers belongs to integers. And the condition should be Q should not be equal to 0. Students, understand the concept of rational numbers. So they are the numbers which can be expressed in the form of P by Q. Which can be expressed in the form of P by Q. Where P and Q are the numbers belongs to the set of integers. Set of integers. And another condition is, so that means the Q should not be equal to 0. That means the denominator should not be equal to 0. Such type of numbers are called as rational numbers. So rational numbers, so they are denoted by the Q. They are represented by Q. So Q equals 0, 1 by 2, 1, 2, 3 by 5, 8 by 3, 7 by 9, etc. So they may include all the natural numbers, whole numbers, integers. So and that means they should be expressed in the form of P by Q. So and another set is irrational numbers. Another set is irrational numbers. So irrational numbers means the numbers which cannot be expressed in the form of P by Q. So the numbers which cannot be written in the form of P by Q, so they are called as irrational numbers. And the set is represented by IR. So IR equals, so this set of natural numbers contains root 5, root 2, root 5, 2 plus root 5, 5, etc. Students, next we will move on to the, so another type of set, so that is real numbers. So real numbers means this is the, so mother of the all the type of sets. So real numbers, this set contains both the rational numbers and the irrational numbers. So if you include, if you include both the set of rational and irrational numbers, so we will get a set of real numbers. So it is denoted by, so the letter R. R means real numbers. So it includes 0, 1, 2, 3 by 5, minus 8, minus root 2, 5, root 5, etc. So that means if you observe the set, so it includes so both the positive numbers, negative numbers, 0, so rational number, irrational number. So therefore, so it is a mother of all these sets. Or simply we can say, we can write R equals Q union of IR. It is a union of Q and IR. That means it is a union of rational numbers and irrational numbers. So after seeing all the types of such students, now we will see the relationship between the different types of sets. So that is n. So n, it is a natural number. So and next one is w, and after that we will have z. So after that, so we have q rational numbers. So and a set of irrational numbers. So this is the relationship between all the types of set of numbers. Here is a set of real numbers. Students, from this is called as a Venn diagram. So Venn diagram, if you observe this, so it contains all real numbers. It is a set of real numbers. So real numbers. So in this number, so if you observe here, it contains natural number. So it means counting numbers. Next, so if we add 0 to this natural number, we will get a whole number set. Whole number set. So if you add negative numbers to the whole numbers, we will get integers. We will get integers. So if you add positive, negative, and the p by q form, so they will form rational numbers. They will form rational numbers. So coming to the irrational numbers, so it is kept outside this group because irrational numbers are the numbers. Already you know that irrational numbers are the numbers which cannot be expressed in the form of p by q. Therefore, it is kept outside these sets. But it is included in the real numbers. But it is included in the real numbers. So this is the relationship between the different types of set of numbers. Now, students, so if you observe the another type of numbers, set of numbers, that is composite numbers. So composite numbers means a number which having more than two factors. So composite number means a numbers so which having more than two factors. That means if the number has a more than two factors, so such type of numbers are called as composite numbers. So example 4, 6, 8, 9. So students observe clearly here we have, if we write the factors of 4, we write the factors of 4, so it can be written as, so the factors are 2 into 2. Factors of 2 are 2 into 2. Or we can write this as 2 into 1. This can be written as 1 into 2. So this is also written as 1 into 2. Or in another way, we can write 2 2s are 4, 2 1s are 2. So therefore, the factors of 4, so that are factors of 4, factors of 4 are 1, 2, 4. Similarly, if we write the factors of 6, factors of 6, 6, if we factorize this, so 2 3s are, so 3 1s are. That means they are 1, 2, 3, 6. So these are the factors. So 4, 6, 8, 9. So in similar way, so we can write the factors for the each number. So here you have to remember that a numbers which having more than 2 factors. So if that number has more than 2 factors, so here for the 4 different times 1 factor as a 1, 2, 4. So for the number 6, so the factors are 1, 2, 3, 6, etc. So if you take another example, so 3, factor 3, factors of 3, factors of 3. If you write, they are 1 and 3 only. 1 and 3 only. So therefore, 3 is not a composite number. 3 is not a composite number because it has only 2 factors, 1 and 3. That means 1 and itself. So therefore, 3 is called as a prime number. Similarly, so for 5, so 5 we can also 1 and 5 are the factors. So therefore, so 3, 5, 7, such type of numbers are called as prime numbers. So therefore, 3 is not a composite number. Not a composite number. Composite. Students, now we will move on to the another set of numbers. So they are co-primes. Co-primes means two natural numbers are said to be co-primes if their HCF is 1. So co-primes means two natural numbers are said to be co-prime if their HCF, the HCF of the two numbers, is equal to 1. So they are called as co-primes. Example 8 and 9, 10 and 15. So for the if you take the HCF of the both 8 and 9, so we will get. So first we will write the factors of the 8. So 2 4s are 2 2s are, and so 2 1s are 2. So if you factorize 9, 3 3s are 9, 3 1s are 3. If you write the factors of 8, so factors of 8 are 2 1. So, and the factors of 9. Factors of 9 are 3 and 1. So, if we take the HCF of both, therefore, the HCF of both 8 and 9. 8 and 9. So, if you observe from this, so 1 is common in both. Therefore, the HCF of 8 and 9 is 1. So, therefore, this two natural numbers are called as 4 primes. 4 primes means the two natural numbers having the HCF equal to 1. Okay, students? So, have you understand the different types of sets of numbers? Student, shall we discuss some simple problems on the number systems, which we studied until. So, if you observe this problem, so in this problem I have given some of these statements. So the problem is state whether the statements are true or false. True or false. Give reasons for your answers. Give reasons for your answers. The statements are. First one is every whole number is a natural number. Second one, every integer is a rational number. Every integer is a rational number. The third statement is every rational number is an integer. Students, so in this simple problems according to the basics of the this numbers system chapter, so we have to state whether the statements which are given below are true or false. If they are true or if they are false, we have to give the reasons. for each of the statements. Students, so if we take the first statement, every whole number is a natural number. That means we have to recall the set of natural numbers and the set of whole numbers. Let's see the set of natural numbers. N equals 1, 2, 3, 4, 5, 6, etc. etc. So the set of whole numbers will be 0, 1, 2, 3, 4, 5, etc. So if you observe these two sets, so and compare them. So this statement, every whole number is a natural number. So if you observe this, every whole number, that means the numbers which are present in the set whole numbers are also present in the set of natural numbers. So observe carefully, students. So in these two sets, so except 0. So all the numbers which are present in the whole numbers are present in natural numbers. So we can say that this statement, that means every whole number is a natural number. This is exceptional because 0 is not included in the natural number. Therefore, this statement is false. The statement is false. Why it is false? Because 0 is not in the set or not included in the set of natural numbers. In the set of natural numbers. Similarly, so observe this statement, second statement. So second statement is every integer is a rational number. Every integer is a rational number. For this, we have to write the set of integers and rational numbers and compare them. So z equals 0 plus or minus 1 plus or minus 2 plus or minus 3, so etc. This is the set of integers. Whereas in case of rational numbers, so it is represented by q. So this can be written 0 or 1, so 1 by 2 or 2 by 3, so or negative numbers 3, etc., etc. That means so they are all in the form of p by q. They are all in the form of p by q. If you observe, compare both the set of integers and the set of rational numbers. So, on comparing those two numbers, every integer is a rational number or not. So, observe this. So, all the integers are, they can be expressed, if the numbers can be expressed in the form of p by q, so then we can say that that number belongs to D, or that number is also present in the set of rational numbers. Students, therefore we can write that, so every integer can be expressed in the form of p by q. Every integer can be expressed in the form of p by q. So therefore this statement is true. Second statement is true because every integer can be expressed or written expressed in the form of p by q. So students, have you understand this? So this second statement is true because every integer can be expressed in the form of p by q. We shall see the one example. So example, so if this 2 can be written as 2 by 1. So 2 can be written as 2 by 1, or you can take any one. So 0 can be written as 0 by 1, 0 by 2, 0 by 3, or anything. So therefore second statement is true. So coming to the third statement, every rational number is an integer. Every rational number is an integer. So students, observe again, once again observe the both the set of the rational numbers and the integers. Every rational number is an integer. So for this, if you observe this, so the set of rational numbers, so it is in the form of p by q, or the numbers can be expressed in the form of p by q. So whereas in case of integers, they have only positive, negative numbers including 0, but they cannot be so in the form of p by q. Therefore, we can say that this third statement is false. That third statement is false. The reason is because the set of integers, does not have numbers like p by q. So that means this statement also states that all the integers are all rational numbers, but all the rational numbers are not integers. So I think you have understand this problem. So now you have to so under three statements are there. So you have to work those three statements and so students now here observe the another three statements. There are another three statements are there. So fourth one is every natural number is a whole number. Fourth statement is every natural number is a whole number. So try to solve this. Whether this statement is true or false by writing the all type of numbers, different types of numbers. So fifth one is every integer is a whole number. The question is every integer is a whole number. So we have to write here whether this statement is true or false. So if it is true or if it is false, we have to give the reasons. We have to write the reasons for it. So lastly, every rational number is a whole number. Last one is every rational number is a whole number. So try to simplify this statement and give the reasons for every statement. Okay. Now, students, we will see the next problem. Next one is 0 is 0 a rational number. Is 0 is a rational number. So if it is a rational number, can you write it in the form of t by q, where t comma q belongs to z, and the condition q should not be equal to 0. That means the denominator should not be equal to 0. So observe the statement of the problem is 0 is a rational number. So if it is a rational number, so it must be expressed in the form of p by q. Student, so solution for this is yes. So 0 is a rational number. I can accept it. Yes, 0 is a rational number. So if it is a rational number, so in the next part of the statement, they have given that. So by the definition of the rational numbers, so it states that every number which can be expressed in the form of p by q. So every number which can be expressed in the form of p by q are all called as rational numbers. So therefore 0 can be written as 0 by 1 or 0 by 2 or 0 by 10, etc. So which is of the form p by q, which is of the form p by q. So therefore 0 is a rational number. Okay, students. We will see the next problem. Next problem. Next problem is find third line. This is the third line. Third line. Find five rational numbers. Five rational numbers. Numbers between for these students, so we have to write the 5 rational numbers between 1 and 2. To write this, we have to convert these 1 and 2. So that means it is converted to the p by q form. P by q form. We have to write 5 rational numbers between 1 and 2. So we have to convert. We have to convert the denominator denominator 5 plus 1 equals 6, equivalent for equivalent to 1 and 2. Equivalent to 1 and 2. That means, so we have to add 1. We have to add 1 for how many rational numbers we are going to write. So if we want to write 5 rational numbers, we have to add 5 plus 1. So if we want to write 6 rational numbers, we have to add 1 for the how many rational numbers we have to write. So and next, we have, if we want to write 10 rational numbers, we are going to add 1 for each. So in generally we know that, so a infinite number of rational numbers between any two numbers. There are infinite number of rational numbers in between any two numbers. So if this 1 and 2 can be written as, therefore, so 1. So this can be written as 6 by 6, equivalent p by q form. 1 can be written as 6 by 6 and 2 can be written as 12 by 6. 12 by 6. So therefore, in between this, so therefore the 5 rational numbers are, the 5 rational numbers are numbers are 6 by 6, that is 1, which is always less than these numbers, and the 2 can be expressed in the form of 12 by 6. So in between these two numbers, we have to write 5 rational numbers. So here it is simple. So go on writing, go on adding the plus 1 to the numerator. So I am writing the denominator as it is. So the next number will be 7 by 6, 8 by 6, 9 by 6, 10 by 6, and lastly 11 by 6. So therefore, the five rational numbers between 1 and 2 are 7 by 6, 8 by 6, 9 by 6, 10 by 6 and 11 by 6. So therefore, you can write the rational numbers. The rational numbers between 1 and 2 are 7 by 6, 8 by 6, 9 by 6, 10 by 6 and 11 by 6. So this is the simple problem, students. So before going to write that, we have to know how many rational numbers we have to write. First, we have to know that. After knowing the how many rational numbers we have to write for that, so if we want to write the five rational numbers, we have to add 1 for that, means 5 plus 1, 6 plus 1, 7 plus 1. So and etc. Similarly, add 1 to that and write the equivalent form of the given numbers. So that means here 1 can be written as 6 by 6. That means in the form of p by q. 2 can be written as 12 by 6. So after writing these two, so in between the given numbers, so just you add the 1 to the numerator and write the denominator as it is. So observe this problem. So 1 can be written as 6 by 6 because we have to write 5 rational numbers. So 2 can be written as 12 by 6. So 6 by 6 here, first number and the next number is 12 by 6. So in between this, so we have to write the 5 rational numbers for this. So 1 can be written in the form of 6 by 6. For this, you have to add 1 to each numerator. 6 plus 1, 7 by 6. 7 plus 1, 8 by 6. 8 plus 1, 9 by 6. 9 plus 1, 10 by 6. 10 plus 1, 11 by 6. So we will get 1, 2, 3, 4, 5. They are the rational numbers between 1 and 2. Now, students, observe this statement. It is important note to while writing the rational numbers or the property of a rational number. So there are infinitely many rational numbers between any two given rational numbers. That means there are infinitely many rational numbers are present in between. So the two rational numbers. This point we have to remember. So we can write so 2 or 3 or 5, 10, 15. So infinitely many rational numbers between any two rational numbers. So in the given problem, so we have write only how much they are asked to write the rational numbers. So this important point to be kept in your mind. Students, now similarly you have to simplify this problem, second problem. Find the 6 rational numbers between 3 and 4. So here you have to write only 6 rational numbers. So but infinitely many rational numbers are there in between 3 and 4. Now we shall see the next problem. Find 5 rational numbers between 3 by 5 and 4 by 5. So in the previous program, students, so we have to write. We have to write. We have to find or write or find. We have to find 5 rational numbers. 5 for this we have to convert. So multiply both numerator and the denominator. Denominator of 3 by 5 and 4 by 5 by 5 plus 1. 5 plus 1 equals 6. So now this can be written as, so therefore 3 by 5 equals 3 by 5 into 6 by 6. 6 by 6. This will become 6 3s are 18, 6 5s are 30. And so this can be written as 4 by 5 can be written as equivalent for these. So multiply, here also multiply 6 to the both numerator and denominator. It will become 6 4s are 24, 6 5s are 30. 6 5s are 30. So now we have to write 5 rational numbers in between those. Therefore 18 by 30. So here it is 24 by 30. So in the previous problem, we are by keeping the denominator as it is and add 1 to the numerator. So here, so this 3 by 5 is converted to the form 18 by 30. So the next number will be 19 by 30. So another one is add 1 to the numerator, 20 by 30, 21 by 30, 22 by 30, 23 by 30. So 1, 2, 3, 4, 5. 5 are the rational numbers between 3 by 5 and 4 by 5. Therefore, 5 rational numbers are rational numbers between 3 by 5 and 4 by 5 are 19 by 30, 20